Let's take a look at a coded up version of an algorithm for finding the minimum in a list of numbers. To show these solutions, I'll generally use the microbit online interface that you've been told about as part of WySLICE. Let's examine what I've done here. Everything on the left on start is just setting up the problem. As you remember, I told you we had a list of 10 numbers, 22, 18, 73, and we're trying to find the minimum, which is 10. I also told you that one constraint is that we would initially put the number 99999 in the box. So everything here in the on start, which is just what will be used to initialize the microbit, is just setting up the numbers in the problem. The actual algorithm I hope you would produce, which will be run when we press button A, which is why it's in this block, this magenta block, was the following. So if you wrote down anything close to this, congratulations. You should have said for number in list, the microbit translates this as for element number of list, but don't worry about small differences in language. For number in list, so you're going through your list one by one, you're going to check the number against the number in the box. And if it's less than the number in the box, you're going to do something. So this was your conditional. And what you're going to do is you're going to change the number in the box. So you're going to update it with the number that is less than, is lower. And this is set box to number. So your algorithm really only consisted of 3 elements. You had to go through your number, each number in your list. You had to apply the conditional. If the number is less than what's currently in the box, we're going to do something. And then you also had to then update the box, set the box to be the number. So I tried to get you to use slightly different language, but hopefully you can see that everything merges up, everything matches, and that the language you chose reflects the algorithm. So the question is, have we got this correct? Well, let's push button A on the microbit and see what the result is. It is indeed 10, which is the minimum. What's going on in practice here is I'm going to number 22, 18, 73, 42, 69. Each number is being compared to the number in the box, which we started very high, 999999. So is 22 less than it is? And if it is less than 9999, we replace 9999 with 22. And then we would go to the next number, 18. Remember, 22 is now in the box, and say, is 18 less than 22? It is, so we'd replace the number in the box with 18. Then we'd ask, is 73 less than 18? And it's not, so we would just move on. Is 42 less than 18? And so on, one by one, comparing the numbers to what's in the box. Eventually, once 10 is in the box, no additional number in the list is less than 10, so what's in the box would never change. One more time, that would mean we would expect to see 10. If you wanted to see what was going on as we went through the algorithm, you could move the show number box up here, and then that will be printed to screen. And you can see that gradually as we work through, it finds smaller and smaller numbers until it bottoms out at 10. Of course, what you're seeing is what's happening each time through the list. So initially it finds 18, it stays at 18 for each of these numbers, and then it goes to 10, and then it stays at 10 for each of these numbers. If you're not certain if this is working, let's change 10 to something else, something large like 99. And let's pick a really small number and put it down here like 3. And let's run it again. Button A pressed. So first time through, 23 becomes the box. 18 is less than 22, so it becomes the box. Then 73 isn't, so we stay with 18. We stay with 18 for 42. We stay with 18 for 69. 31 is not less than 18, so we stay there. 99 isn't. 92, there's going to be no change. But here we're going to hit the number 3, and there it is. It's less than what was in the box. And then it's just going to stay until the end of the run through the list. So there's one possible algorithm. And we can verify that it works using the microbit. Another question I asked you is, do you have to touch every single number in the list to find the minimum? The answer is yes, you absolutely do have to touch every single number in the list. As I mentioned when I introduced this problem and we had a smattering of numbers all over the screen, there's no way of knowing that you found the minimum number without comparing it to every other number on the screen. So you do indeed have to compare to every number to be absolutely certain you've reached the minimum. Another question I asked was, how would you change your algorithm to find the maximum instead of the minimum? Well, that's pretty simple. You would flip your conditional, so you're looking for the number that is greater than box, and you would have to start your box with a really small number. But with those two changes to your algorithm, we would hope now that the maximum number will be found. Let's change it to something memorable like 97, and let's see if it does indeed find the maximum. When we press button A, it does indeed, it finds 97. Switching back, we would hope it finds 3 again. And that's one more time. It does indeed. So that's the basic introduction to algorithms. Tomorrow we'll expand on this. We won't just consider minimum and maximum numbers. We'll try and sort the numbers in the list in order so they run from the smallest to the largest.